In this video, I'm going to demonstrate how we can first of all do a general track extraction on some rail data and then pass more accurate templates along those extracted lines to do a much more accurate rail track extraction, and then finally we'll complete by doing a overhead wire extraction. So to begin with, I'll start a new model just for the rails. Go to the 3D view and load the point cloud. Okay, so I have some data ready to rock and roll. So the first thing I need to do is go to Feature Extraction tab. Okay, and the Feature Extraction tools are a bolt-on for Designer, they're not standard in Designer. And I'm going to use the Rail Track tool here. And what we do is we load in our preset, so I've already got this set up ready to go. But essentially we're looking for data sort of within a 200mm high box by 40mm wide every time I drop down a seed. So I'm going to do Add Seed, and we'll start down here. And just make sure I've got it set to nearest, so it's going to click on the top of the rail for me. And we'll put one seed going down like that, and another one next to it. Okay, if you need to, you can readjust by right-clicking and choosing Rotate. Okay, so now if I just hit Extract, we'll see what happens. Okay, so that did a reasonable job. So what I'm going to do is I'm going to clear that and now add the rest of the seeds. And you'll join me when I'm finished. So I now have a seed put down on each of the rails I want to do a rough extraction on. All I need to do is hit Extract. Okay, and they all go. They look like they're all running nicely. And they'll stop when they run out of data. There we go. So, yep, they stopped when they get to the top, when essentially the scan just thins out to the point where the criteria can no longer be met. So, what I'm going to do now is I'm going to just put my code in. Here we have it, CL for centerline, and I'm just going to hit Commit All, and then right click to cancel, and there you have it. There's all our features. So if I just temporarily turn the point cloud off, there you have them. Okay, so these are the lines that we're now going to use the ICP tool on to do template matching and actually do a proper, more accurate track extraction. So the next stage is then to employ the ICP tool. So ICP stands for Iterative Closive Point. Fundamentally it's a way of aligning point clouds, but we're going to use it in a 2D fashion. So if I click this tool, the first thing it wants is a CSV. So this CSV file is a file which we've actually created ourselves, and essentially it's just a trace of a template. So by template I mean something like this. Okay, so I loaded this image into n4ce, drew over it to scale, or drew half of it, shall we say, and then mirrored it, and then turned that into a CSV file. So I created points at all the appropriate locations, and then you'll see in a moment that we can densify that as we need to. So when I click Load CSV, it'll allow me to pick a CSV that I've created already. So here's that CSV. I have my template now. You can see the template is previewed for me down in the corner here. Now, what we're fundamentally going to try and do is we're going to try and now take a series of sections along each of these rails, and then n4ce is going to try and match this template to each section. So I'll start then by telling it what string to use. Let's start with this rail. And then I'll show the section view, show the path. If I hit zoom to section, there's our first section. Okay, now my section is currently 150mm wide, 200mm high, and only 20mm deep. So let's try and increase the depth to use more points. Okay, so you can see as I change the parameters, n4ce is going to update the preview for me. So the main settings are the cluster radius. So you can essentially imagine this side here as one cluster, and this side here perhaps is another cluster. And by changing this value, we can set it to a point where only this side is one cluster and only that side is in another cluster. If I make it large enough, it'll actually join it all into one cluster. n4ce will try and match the template to the best cluster, essentially. So we're going to see the results of n4ce matching this to the best cluster. Now the best cluster is probably obviously this side here for this one. If I double click the next template and the next template and the next and so on, you can see it changes. So what I'm going to do is I'm actually going to tell it to only use half of the points, shall we say, this side here. So rather than template start at 0, which would be down here, let's see what happens if I set that to say 50. Okay, that again changes the solution, but it's still not good enough. You can see that's obviously not ideal. So I'm going to just, with the mouse, click in there and just change the points. Okay, and wind it down here. Now what we've got to be careful of is that it doesn't flip like this. So you can see the template is actually here, and the point we're trying to extract is this one here. If I was to say go to the right, it will flick to that side, but obviously we need it set to the left. Okay, so currently it's deciding that cluster there is going to give us a better result. If I try using the whole, let's say it's a 50, it's now treating the whole thing as one cluster, and now I can play with the point density again, point density on the template, to try and get a good match. And that's currently fitting to 2 mil, and that's probably not a bad solution. Let's see how it ties in here. Yep, that's doing alright. So what we're going to do then is we're going to try and apply all of these settings to every single section down this line. Alright, so I'm going to enable this option here, compare to previous fit. So by doing that, n4ce is going to store the results for each of these section locations, and I can run it again and again and again, and it will only update each of these locations if there is a better fit. So that way I can change the settings multiple times, keep running the fit, and it will only update where you get a better fit. So that way you don't have to have one set of defaults for the entire line of the rail, because obviously if we're dealing with static scans as this is, our aspect, the rails are constantly changing and we're not always going to get a constant view, so we have to be able to change our settings to accommodate that. Currently our maximum error is 5 mil, and I'm going to just tell the system that this is a good rotation, so then it's going to compare any subsequent extractions to this location, and I don't want anything more than say 5 degrees relative to this one, and hit fit templates. So now it's going to pass those settings all the way down, and you can see it's now got 258 out of 286 locations that are passed. So that one probably won't pass to a certain degree because it's not got enough data. It's saying that's failed, but again, given that limited amount of data, we could probably actually accept that one. So if I say use current fit, it'll actually keep that one and accept it. If I hit that button there, it'll go to the next failure. Okay, so we've got some failures here, so if I double click that, so here you can see again that we've got a slightly different view of the data. So I'm going to change the settings again to suit. So let's try maybe 30% to around 70%. So if I put 30 in there and 70 in there, what does that do? There you go. So now the purple is the previous fit, the green is now what we're working with at the moment, but still only using these points here. Okay, so 30 takes us to here. If I say 20 and say 80, what happens? There you go. So I could probably lower this more and increase this one to use more of the available data. So that's fitting to within 2 mil. I'm happy with that. So currently we're on 258 out of 286. So if I do fit templates, it will only fit the ones where it gets a better fit. So hopefully these are going to go green now, which indeed they do. And we're now getting 281 out of 286. So that's pretty good. Okay, so I'm going to be I'm happy with those. So it's already got a code in here, RL. So I'm going to just say RL1. Okay. And if I hit digitize P points, it will now create that string for me through those P points, which you can see there. So if I right click to cancel, you can see this magenta line is in fact what we're looking at. Okay. If I go to sections and if I now do slice strings, you can see that point there is the point that's extracted. Okay. I set the interval to say 5 meters and do advance. You can see that no matter how the rail data changes, we're getting a pretty good extraction. Okay. I obviously want to repeat that for this next rail. So if I go back to the ICP tool, and I'm going to hit pick string, and I'm going to pick this string here. Yes, I want to do another load of sections. Okay, so if I go zoom to the first section, update its settings, because we've got obviously a slightly different view of the rail this time. Let's bring those down, increase the other side. Okay, that's not a bad fit, so let's try that. So we'll do fit templates, see how many of those pass. So 223 out of 298. So that one there, if I double click it, that one's failed. Probably because of the noise down here, but as these are every meter, I'm not going to worry too much about that. So there's a few here, every odd one, so I'm going to change the settings again to suit. Try and get a better extraction. You can see as I change the settings, you'll get a different preview. Now at the moment this is clustering the whole thing, but these points over here are obviously throwing it out, so I'm going to change that back to say 20. And there we go. It swings into a better fit. And hit fit templates and try those settings everywhere. So now we're getting 246 out of 298. So this one's failed. So this one's failed probably because of the rotation issue. So you can see it's 9.6 and it is slightly off, even though it's got a reasonable fit, the rotation's not great. So to try and fix that, let's use some of the points down in the web. Lessen them from the other side. There we go. And hit fit templates. Okay, 276. Okay, so that's filled those ones in. Okay, and before I digitize this one, I need to make sure the P point is on the other side. So rather than left, we're going to go right, and now I can hit digitize. Okay, I could also extrude the mesh. I didn't do it on the other side, but if I do it on this side, you'll be able to see the results of that as well. Okay, so if I right click everything to turn everything off, turn the point cloud off, turn off the section view. Okay, so if I put it in wireframe mode, you can see how the template's been extruded to give us a decent rail, and then we've got the P point, how the template's been extruded to give us the mesh, and how we now have our much more accurate theoretical running edge given to us by the template. And it's just a matter of repeating that for each of the rails that we've already done the rough extraction on. Now we can move on to the overhead wires. Having extracted the rails, we're now going to look at extracting the cables. So the first stage is to, under feature extraction, click on the cable extraction tool. I've already tuned these settings to get the best extraction possible. So the first stage is to add the seeds. So if I add seed, I'm going to start with the contact wire. So 1, 2, 5. And just to make things easier, I'm just going to adjust the clipping box so that we don't see the rails. Okay, so I think we're ready to give it a go. So if I hit extract, Okay, so how have we done? So that one's worked okay. This one's control click in there. That's diverted across there. That's okay. That one's done fine. Yeah, okay, so I think that's what's happened here. Okay, yeah, it's all diverted as it should have done. So those are all contact wires. So I'm going to select the contact code and hit commit all. And if I do show through cloud, we can see that. Okay. So there's obviously some places where I've got to start another contact extraction. So having cleared the seeds, we'll do add, and we'll put another one going that way, and hit extract. Okay, that seems to have done its job nicely. So I can right click on this one. I don't have to do commit all, I can do commit and remove. And there's one more to do here. So again, we add, we'll start there and go that way and hit extract. Okay, so let's see how that one's done. It's correctly gone through there. Okay, but here it's jumped. Okay, so let's commit it, and then we'll go back and fix what we need to fix. So do commit and remove. Okay, so we'll start a new extraction, and then we'll join it all up afterwards. So we'll add, and then hit extract. Okay, and then we'll do commit and remove. Now I'll turn the point cloud off because it'll make it easier to see what's going on. Okay, let's turn the points on as well. So if I go hit break and then tidy up these points, so delete that one. You can delete that feature as well in a second. So if I hit now join and then delete that one, and that's just a matter of tidying up the data. So let's put the point cloud back on so we can see what we're doing. So delete that point there, delete that one there. There's some in here that can probably be deleted. Okay, and that's done a reasonable job. There's obviously a bit more editing to do to make it ideal, but that will work for now. So now I'm going to repeat the process for the catenary. So I'll change my code ahead of time. I'll add seed. So let's do this first one here. I'm going to right click and say use high points. So now when I add the next seed, it will remember that. Okay, this last one here. Let's extract that and see what happens. So with some editing, that one's done okay. That one seems to have done okay. That one's done okay. And I think that's done okay. So we can hit commit all, clear, and then we can just infill where we need to. So here's one location. Okay, so let's extract that one and see what happens. Okay. That one seems to work properly. So we'll do commit all and clear. Let's turn the point cloud off. So we've got the contact wire missing from here, so let's turn the point cloud back on. So add another seed for that. Hit extract. Commit and remove that. Okay, so there's obviously some editing to do in places, so I'll just quickly run through some of those. So we'll just delete point. So just so we can see why that happened, if I turn the point cloud back on, there we are, that's why it hit that structure there. So I'm going to delete that point there. Okay, so delete the necessary information as you see fit. So at the ends, it's quite often gone through the structures. So if I use the break tool there, I can then use delete. Okay, here we've actually got a position where the contact wire has actually jumped to the lowest part. So I'm going to delete that one and redo it. Okay, we'll start that one again. Okay, I'm going to change a little setting. Make it use the high points, which you should have done first of all, and change this value to 1. Try that. Okay, that's definitely come out on top this time, and has done a better job, yep, of going through. So the setting I just altered there is just another way of also helping it to use the higher data rather than the lower data during the extraction. So I will commit that and clear. Okay, now to add it all together, I can just go to Home, go to Backcloth, and let's just bring in the other models. So there's the meshes, and here's the rails. Get rid of the clipping, and then turn off the point cloud. Let's put that into wireframe. There you go. So the rails. So there we go. There's our extracted P strings, P points, and there's our OLE.